Right, so this one is the trickiest one, trying to find the derivative of the square root of x using first principles. Okay, now the thing with this is there's no advantage at all to change it into x to the power of a half. We're actually just going to keep it as a radical because it doesn't help at all changing it into exponents. Okay, so the first thing I'm going to do, of course, is put it into my formula. F dash x is equal to the limit as h tends to 0 of, so it's going to be the square root of x plus h minus the square root x all over h. Okay, so this, now, you can't easily subtract square root of x from square root of x plus h. You just can't do stuff with this. So what we're going to do is we're going to use the same kind of like mathematical trick, if you like, that we did when we rationalised the denominator. What we're going to do is we're going to multiply this whole thing by the conjugate of the numerator. So this is going to look like this. Okay, I'm just going to drop the limit for now. So we've got x plus h minus square root of x all over h. Now I'm going to use a different colour. I'm going to multiply by the conjugate. Now the conjugate is the same terms, so it's x plus h, square root of x plus h, and the square root of x, but it has the opposite sign. And we can only do this if we make this equal to 1. So as long as I'm multiplying by 1, I can do this. I can get away with this trick. Okay, now the reason why I'm doing this is essentially on our numerator now, what we have is we've got a minus b times, okay, in orange, a plus b. Difference between two squares, and that is equal to a squared minus b squared, because the terms in the middle cancel out. So what we're going to get here is on a numerator, my first term, which is the a, is the square root of x plus h. That gets squared. And then it's going to be minus my second term, which is square root of x. That's going to be squared. And our denominator is now much uglier than what it was. We've got h times square root of x plus h plus square root x. Okay, now I can definitely tidy this up because the square of the square root cancels out. So what I end up with here on my numerators is just x plus h minus x over, I still have this very ugly thing on the bottom, so we've got x plus h square root plus square root x. Now of course you can see that we've got some cancelling that we can do here. X minus x is 0, so I'm going to get, okay, let's see if I can put this in, h divided by h times square root x plus h plus square root x. Now also, once again, we can cancel now. Now you have to be a little bit careful here because you need to remember to write your 1. Okay, I'm going to have to move over here. What have I got? I am left with, and I'm going to come back and write this again, the limit. So I'm trying to find my derivative. So the limit of h tends to 0, I've got 1 over square root x plus h plus square root x. Okay, now I'm going to apply the limit. I'm going to let h tend to 0, and what that is going to give me is 1 over, well, square root of x plus 0 is just square root x plus square root x, which of course is just equal to 1 over 2 square root x, which is our derivative of, so this is equal to f dash x, that's our derivative of our original equation, which is the square root of x.